All right, well, let's get started. Firstly, thank you all for taking the time out of your day to join Aceinna and our friends at WPG Americas for the second webinar of a series in as many months. And we hope that all of you are staying safe and social distancing as need be. We would appreciate to have this conversation face-to-face, but in our current environment, we will do this over Zoom. But I just wanted to say thank you to our friends and colleagues at WPG Americas for sponsoring this alongside of Aceinna. A little bit about Aceinna. We are focused on powerful sensing solutions at the highest performance at the best value. And we do appreciate the time. This will be a technical review of developing custom CAN messages for our OpenIMU300RI and MS VS Code. So with that, I'm going to turn it over and introduce Ravi, who is one of our application engineers based in our Santa Clara office. Ravi, if you could take it over, we'll get started.
Okay. Thanks, Michael. So in this webinar, we're going to cover different topics, which includes getting familiar with the OpenIMU300RI Eval Kit, giving you a brief overview of software development environment, brief overview of Aceinna Extension in Visual Studio Code, importing project example and talking about its structure, and then we will create a high-resolution acceleration CAN message, and I will walk through all the steps that needs to be done in the source code, and then building the source code and then uploading to the unit. And finally, we're going to check the output results on the CAN tool. We're going to have the questions towards the end. So getting started, OpenIMU300RI Evaluation Kit. So let's take a look at what all the products that we have in the OpenIMU family. The first one we have is OpenIMU300ZI, which is 9 degrees of freedom, and this is used for embedded application, and it has SPI and UART as interface. The second product we have is OpenIMU300RI. It comes in 9 DOF. That means it has a 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer. And it comes in a ruggedized casing with IP69 rating. And it has CAN and RS-232 as interfaces. The third product we have is OpenIMU330BI. This is triple redundant with 6 DOF. That means it has a 3-axis accelerometer and 3-axis gyroscope. This is surface mount with the BGA, which is a ball grid array packaging, and it has SPI and UART as interfaces. So when you place an order for the OpenIMU300RI Evaluation Kit, so these are the following components that you'll get in the kit, which is OpenIMU300RI IMU module, which is fixed mounted in a precise location on the text fixture adapter, as you can see in the picture. And it comes with a ST-Link JTAG pod, along with the debug cable and the USB cable. And it has a cable AMP-sealed 16 6-position to DB9, which consists of CAN 2.0 connection DB9 and RS-232 connection DB9. And it has a flying leads to connect to the power connection. So let's take a look at the main features of this OpenIMU300RI. This is an open source IMU, which 9 DOF. That means it has 3-axis accelerometer with a range of plus or minus 8 Gs, and 3-axis gyroscope with a range of plus or minus 400 degrees per second. And it has a 3-axis magnetometer. Comes with CAN and RS-232 as interfaces. And this is an open source module. That means we have like ready to use algorithms that you can download from our website, and you can change the source code based on your needs and application. The applications that we have right now is the IMU application. The second one is vertical gyro, attitude, and heading reference system application. This application gives you the complete attitude, which is roll, pitch, and yaw information. Third application is inertial navigation system application. This requires that you connect the external GNSS receiver. So with that, like, you can get the complete INS solution, which means it has a position, velocity, attitude, and acceleration and rate biases as well. So this comes in ruggedized plastic overmold sealing packaging. So software development environment. So I'm going to give you a brief overview of what all the software development environment that we have. This topic I've extensively covered in my previous webinar. So in that previous webinar, I've given you a live demo as well. So if you want to take a deeper look into this particular topic, so I recommend you to go to my previous webinar, which I will provide you the link as well. So the Aceinna hardware comes along with a suite of software tools, which consist of free software IDE, which is Visual Studio with Aceinna Extension. And the ST-Link drivers and the utility tool that you can download so that you can upload the binary file onto the unit. We have like Aceinna Navigation Studio. This is a web-based GUI tool, which you can use for real-time data collection if you want to run any simulation. And it has an app marketplace where you can upgrade your unit from the web GUI tool. And we have all the source code available on the GitHub, which includes all the algorithms. And if you want to change any IMU configurations, all the source code is readily available on GitHub. And we have complete documentation available for all our products, talking in detail about the settings, configuration, and the parameters. Everything is available online. And we have a support forum as well. So I've talked all these tools in detail with the live demo in my previous webinar. The link is provided below as well. So getting started with the installation of the PC tools. So we do support different platforms, which is Windows 10 or 7, Ubuntu, the Mac OS. So make sure you have ST tools installed along with the drivers and the ST-Link program utility. Install the latest Python. And we do recommend to have the Chrome browser as it's much more compatible with our tools. So installation of Visual Studio Code and extensions. So once you download your Visual Studio Code based on your platform and operating system, while installation, we suggest to ensure you have Add to Patch selected during the installation. So once you have the Visual Studio Code installed on your PC, and go to our extension and search for Aceinna, and you can install the Aceinna extension as well. So whenever you open the Visual Studio Code, the Aceinna homepage appears, and it gives a lot of information about if there's any latest upgrades to your source code platform. So everything will be highlighted over here in the libraries or source code so that you can update all the source code regularly. So in the similar fashion, we recommend installing the Python extension as well. So Aceinna Navigation Studio. So this is a web-based GUI tool, which is used for deploying the algorithms directly onto your OpenIMU hardware. And once you have the OpenIMU hardware connected to your PC, you can check the real-time data display, and you can capture the data, analyze the data, everything on the real time. And we have the simulation tool available as well, where you can easily create virtual IMU, the motion trajectory, and do the algorithm simulation as well. So the link is provided as well. So Aceinna Forum, we have a great Aceinna Forum for the community. So where you can discuss different topics, which includes navigation or general topics in regards to the GNSS receiver, initial sensors, etc. So if you have a particular question in regards to any particular product, you can pose that question over here, and we have a great technical support team who are very quick to answer any questions and get it solved. So this is a great way that you can get in contact with our technical support team. So connecting to OpenIMU300RI unit. So let's take a look at the OpenIMU300RI Eval Kit connections. So the components that we have are OpenIMU300RI IMU module, which is precisely fixed onto your text fixed adapter, as you can see in the picture. And we have the ST-Link JTAG pod along with the debug cable with the USB cable which is connected to your laptop. So this is used to program your IMU product with the source code changes that you're making on your computer. And we have cable AMSIL 16 6-position DB9 connector. This has CAN 2.0 DB9 and RS232 DB9. And we have like 2 flying leads which are connected to power connection to 12 volts to 24 volts. So this power supply doesn't come along with the eval kit. So the documentation is all available online, which has a detailed information about all the connections, the pin configurations, and all the settings as well. So importing the application project into Visual Studio Code. So we highly recommend backing up the image before doing any software development. For this process, you have to use the ST-Link programming utility tool. So connect your ST-Link debug to the OpenIMU eval kit and to your PC, and the power on the evaluation kit, and start the ST-Link utility on your PC. Then click Device and Connect. So enter the size value, which is hex 80,000 for OpenIMU 300, hex 20,000 for OpenIMU 330. So once you enter the size, and then you can click the file and save as, so that you can save the binary file to your desired location on the local drive. So this image will help you. So in case like if your unit got bricked or it's not responding, and you can recover the unit with the help of this backup image, as it consists of all the calibration data for the particular unit. So importing the IMU application code. So as always, highly recommended, save the image before doing any edits, as it preserves all the calibration data that we talked in the previous slide. So next, open the Aceinna extension in the Visual Studio Code. And from the custom IMU examples, select OpenIMU300RI and IMU application. And then you can click Import. So IMU application project loads into the workspace on the left-hand side, as you can see in the picture. So let me give you a quick demo at this point. So open your Visual Studio Code. So when you open for the first time, as you can see, Aceinna homepage always comes. So this gives you a lot of information, what is happening with the latest news as well. So in terms of like software, if you have like latest updates that are available for your libraries and platform, there's a red mark indicating there are updates available for your library and platform. So this is a great way that you can keep updating to the latest updates Aceinna provides. So you can go to the custom IMU example and select So based on your product, the product that we have is OpenIMU300RI, and I will select the IMU application, and then you can click import. So once you click import, it gets imported into the workspace, as you can see on my left-hand side, and it loads all the files. So next one is understanding the IMU project structure. So source code overview. So OpenIMU hardware runs on OpenStack, which is written on top of standard ARM Cortex libraries. It consists of OpenIMU core and the user source code. So this open source stack includes SAE J1939 CAN standard messages that you can directly use or else customize based on your application and needs. So all the source code is available on the GitHub Aceinna. OpenIMU core firmware consists of different functions and elements. So as you can see, we have like different functions, and on the right-hand side, these are the files and the libraries that are located. So it consists of a port support package and the free RTOS. So these are stored in free RTOS, the free RTOS M4 folder. And it has like default pre-filtering and calibration functions. So calibration and the data sampling functions are stored in the library file, which is census library census.a. And the filter functions are stored in the platform filter directory. We have like a default data acquisition functions. So these functions and drivers are stored in the library file census, library census.a. We have default CAN and UART messaging functions. The messaging functions are stored in the file location, source, user messaging can.c file. Also, there are some other files which are located in the directory platform, CAN, and source. Coming to the serial messaging functions are stored in the user messaging ur.c file. So default serial debugging functions. So these functions are stored in source, user, data processing, and presentation.c file. The bootloader. So the source code is not public, but we have bootloading procedure, which are added to the Aceinna Navigation Studio that is provided online. So we have Python-based message decoder and encoder list. These are defined in the file OpenIMU.json. Finally, we have data capture functions which support the Aceinna Navigation Studio. These message descriptions are added to file OpenIMU.json file. So all these functions and elements are in detail explained in the online manual. So all the documentation, everything is available online in the link below. So editing the source code. So most of the source code edits done by the user will be in this files, like source and the user. So these are most of the files that the user can change in terms of algorithm edits or any interfaces. For example, today we are using OpenIMU300RI, which consists of CAN interface. So if you want to change any CAN user messaging, you can change in this particular file, which is user messaging can.c. And if you want to change any related to UART, you can change it in user messaging UART.c file. So we have like OpenIMU.json file, which is useful for describing the input and output messages, any configuration parameters for your OpenIMU. So this is useful for customizing the GUI to user-specific messaging and settings without doing any additional coding. If you want to add any particular or change any CAN message packets, so you have to go further into a different folder, which is .pio, libdepends, platform, and CAN. This is where we have the CAN header and the CAN source files that you can change, which I will talk in detail in the further slides as well. So add custom high resolution acceleration CAN message. So before that, I would like to just talk briefly about what exactly is a CAN. CAN is a controller area network, which is a serial network technology that provides faster communication among ECUs. It is designed for automotive industry, industrial application, other application. So CAN is used in vehicles for communication between ECUs, sensors, actuators, as you can see in the picture on the right side. So this CAN protocol is very robust. It is a low cost, and it has a good broadcast communication mechanism. And we can set the priority for the messages that are on the CAN network, and it has a good error capabilities as well. So SAE J1939 is a set of standards, the higher layer protocol based on CAN, and especially developed for the vehicle application, and it is widely used in construction and ag market. So SAE J1939 specification provides direction for physical layering, diagnostics, several layers of messaging architecture. So you can get a full list of J1939 standards from the link provided below, but you have to purchase based on the set that you want to get it. Add custom CAN message. So why do we have to add custom CAN message? So SAE J1939, which is a standards, defines the CAN messages for a lot of different sensors. For example, if you take an IMU sensor, it has acceleration and rates available in SAE standards with a predefined resolution and range. As an example, on your right side, you can see in the figure, there's a lateral acceleration and longitudinal acceleration, which has a data length of 2 byte, which is 16-bit, and it has a resolution of 0.01 meters per second squared per bit, and it has a data range of -320 to +322.55 meters per second squared. So this predefined resolution and range may not be optimal for your product based on your application needs. So that's where the necessity arises that you have to have a better resolution and range for your products. So that's where we created our own custom CAN message. So custom CAN message. So we have created this custom CAN message, which has like 19-bit per axis, custom high resolution acceleration sensor data message. So let's take a look at the structure for this data packet. So CAN ID format. So the CAN ID consists of priority, which we define it as 2, and the PGN is 65388. So SAE J1939 provides a list of PGNs that you can use for your own custom application and custom messages. From that list, we have chosen this particular PGN, and we have defined the PF as 255 and the PS as 108. And the source address, that's going to be a dynamic based on your sensor that is connected to the CAN bus. And the payload, we have defined it as 8 byte. So looking at the payload structure of this particular high resolution acceleration sensor message packet, so this consists of 8 byte Little Indian format. So acceleration X, Y, Z are of 19-bit each and are sequentially allocated. And the range is defined between -320 to +321 meters per second square. And the resolution is 0.01, 0.00125 meters per second square per bit. So this is much higher resolution when compared to the SAE standards that we just saw in my previous slide. And we have defined the offset as 320 meters per second square. So let's take a look at what all the steps that you need to follow in order to add this custom CAN message to your source code. So the first step is you have to populate the message payload. So this payload needs to be added to the file, which is user messaging can.c. Second step is defining the payload for this new data packet. This new data packet structure needs to be added to the file sae_j1939.h, which is a header file. The third step is defining the message header and build the final message. So this message header needs to be added to the file sae_j1939_slave.c file. The fourth step is choose the next available bit mask. So why do we have to add the bit mask? As you all know, the bit mask is useful for turning on and off a particular message. So if you want to turn all the messages, like if you want to broadcast all the messages, you can enable all the bits. But in case if you want to only on this particular custom message, then you can enable this particular bit and you can disable all the other bits. In that case, only this particular messages will be outputted on the CAN from the product, on the CAN bus. The fifth step is add PDO format and PDO specific from the data packet structure to this particular file, which is sae_j1939.h file. And the final step is if you want to make this data packet message active by default, then you need to add this data packet type to the file, which is user configuration.c file. So I will go through each and every step, talking about how to add the source code to your project directory and what are the files that needs to be updated. So the first step is the message payloads needs to be populated. So this is the source code, the right side. So I've defined acceleration XYZ based on the structure that we define along. We added the offset, which is 320, and multiplied with the resolution. And I've added the 0.5 to make it to the nearest integer. For figure of merit for the lateral, longitudinal, and vertical, I've defined it as 3, which is not defined. But based on your application needs, if you want to use this figure of merit, you can add the particular logic to this code over here, and you can change the value based on your requirements. So this payload needs to be added to the file user messaging can.c. The second step is defining the payload for this new data packet. So this is the payload, the structure of this custom message based on the structure that we defined, the acceleration XYZ, which is a 19-bit, and the figure of merit is defined for 2-bit. And this data structure needs to be added to the file sae_j1939.h header file. The third step is you have to define the message header and build the final message. So the message header needs to be defined, in which we define the priority of this particular message and what is the PF, the length, which is 8 byte, which is 64-bit payload. The PS is defined as well. So this message header needs to be added to the file sae_j1939_slave.c file. The fourth step is add the packet type bitmask definition to the file sae_j1939.h. So whatever is the next available bitmask that you can add it to this file. The fifth step is getting the PDO format and PDO specific from data packet structure. Based on the structure that we defined, the PF is 255 and the PS is 108, that you can add it to your the file, which is sae_j1939.h header file. And the sixth step is if you want to make this data packet as active by default, so whenever you turn on the unit, or if you want this particular message to be outputting by default, then you need to add this data packet type to the file user configuration.c. So this is the file where all the default settings are stored. For example, if you want to change the data packet rate, so by default, all the data packets are coming at 100 Hertz. Now, if you want to change it to 50 Hertz, then you can change it to the value 2. And if you want to 25 Hertz, or you can change it over here. So the filter values for low pass filter for accelerations and rates, which is 25 Hertz by default, or you can change the value in here as well. So the default orientation is defined as +X + Y + Z. So all these default values and all the different configurations and parameter list are extensively, and everything is detailed explained in the online manual. So let me give you a demo at this point of time. So open your Visual Studio Code. And this is the project structure that we're talking about. So the first step that we talked about is you have to do the message payload needs to be populated. That needs to be added to the file user messaging can.c. So I copied the code in my text document so that I can copy and paste it. So this is the message payload that I've defined based on the structure. So then you have to go to the file, to the folder source, and click user, and go to the file user messaging can.c. So in this file, you can see all the other messages that are defined and populated. So as you can see, the acceleration packet, this is the acceleration based on SAE standards. So right below it, I'm gonna copy my high resolution raw acceleration can packets that I've defined based on my structure. As you can see, XYZ I've defined with the offset and the resolution, and I've added 0.5 to make it to the closest to the nearest integer. The figure of merit is defined as 3 right now. So then you can click save. And the second step is you have to define the payload for this data packet. So I'm going to copy the payload that I've defined. So this payload needs to be copied to a different file, which is stored in a different location. So you have to go to .pio, then libdips folder, to the platform folder, and to the can folder, and then include. So this is where we have the file SAE_J1939.h. So click on it. And if you can go down. So this, as you can see, this is where all the payloads have been defined for all the other messages based on the SAE standards, J1939. So we have the acceleration over here. I'm going to define my own custom acceleration message structure over here. I've copied it. And then I'm going to save it. Going to the third step is you have to define the message header and build the final message. So I define the message header. So this message header needs to be added to the function in the file, which is located in, if you come to the source folder, which is located in SAE_J1939_ file. So click on it. So as you can see, so these are all the other messages, which is angular rate and acceleration. These are defined based on this SAE J1939 standard. So I'm going to copy my custom message header definition over here. So this is my acceleration, high resolution acceleration data packet. This is the PGN. This is the hex value of this PGN. FF60, and I've defined it over here. As you can see, I've defined the priority as 2, and the PF is 255, which I haven't defined it yet. I'm going to define in the later steps. And the length is 8 byte, which is 64-bit, and the PS, we're going to define it as 108. So once we define, these errors will be automatically gone. So I'm going to save it. And the fourth step is you have to define the next available bit mask. So this is the next available bit mask that I'm going to copy it, and this needs to be added to the file sae_j1939.h file. We have to go to, so this is where all the bit mask definitions are stored. So the next available bit mask after 100 hex value is 200. So I'm going to store my bit mask for this custom message over here. I'm going to save it. And the fifth step is you have to get the PDU format and the PDU specific for this data packet that needs to be defined. So this PDU format I've stored, which is 255. This has to be defined to the file sae_j1939.h header file. So that needs to be defined to go all the way up. So this is where all the PF definitions are defined based on the standards. So I'm going to store it over here, paste it. I'm going to save it. So you can see all the comments that we have thoroughly organized the code. So you can place it based on the comments in the correct location. And then the PDO format specific needs to be stored as well, copy. And you have to go to the same file, which is sae_j1939.h, and go to the PS definitions. And so these are all the PS definitions based on the standards J1939. So I'm going to store my PS definition for my particular custom message as 108 over here. And I'm going to save it. And the final step is if you want to make this data packet active by default, so you have to copy the data message packet type, which we defined, and you have to add it to the file. This is in the user, the source user, and user configuration.c. So if you go in there, so this is where all the default user configurations parameters are applicable. So these are the ECU packet types. So these are all the messages that are getting outputted by default whenever you turn on the power for the unit. So I want to add my message to this particular list as well for that. So I've copied my particular custom data packet type message over here. I'm going to save it. So if you look in further in this particular file, we can see all the other default settings. For example, we talked about the data packet rate, which is 100 Hertz by default. If you want to change it for 50 Hertz, you can change this value to 2 and so on. The low pass filter values is 25 Hertz by default. So you can change it over here. And the default orientation that we talked about, which is the +X, +Y, +C. And you can change the value as well over here. So we have all the other different parameters which are default, but you can change it based on your application and your needs. So all these default settings and the parameter list are all defined in detail on the online manual. So save all your changes. The next step is building the source code and uploading it to the unit. So once all your code changes has been done, save it. So connect the ST-Link programmer debugger from PC to the JTAG pod on your eval board. Then on the ribbon at the bottom page, click Build. It's going to successfully build. And if there are any errors in your source code, and it will show up over here, and you can go to the particular line and you can debug your bugs or any errors in your source code, and you can build it. Then you can upload the source code onto your unit. Then IMU is now programmed with this new high resolution acceleration data packet. So for building and uploading, it just takes like few seconds. So as you can see, like less than 6.8 seconds. So let me give you a quick demo at this point. So make sure all your changes are saved, and then you can click the build button on the left side on the corner. Once it gets built, and when it is successful, then you can click the upload button. Then it can upload the source code, the binary file onto the unit. So after everything, all the uploading is done successfully, then you want to check and display, make sure this custom CAN message is getting outputted by a OpenIMU product onto the CAN bus. For this, you can use any CAN tool that is available with you. So I'm using CAN Komodo tool. So I've connected my CAN tool cable from PC to DB9 socket of the eval board. So make sure you have 120 ohms termination on your CAN bus. So then open the CAN software tool that came along with your CAN tool. So click connect so that it can detect the CAN tool that is connected to your PC, and click run. And it's going to run, and it's going to show all the available messages that are getting outputted from the OpenIMU product onto the CAN bus. So as you can see, our new custom CAN message is getting outputted as well. Then you can click record to save any IMU data and export it for further analysis. As you can see, all this message getting outputted on the CAN tool software. So let me give you a quick demo at this point. So open your CAN software tool. So click connect so that it will detect the CAN tool that is connected to your PC, and select it, and then click play. So as you can see, all the messages that are getting outputted by the OpenIMU300RI onto the CAN bus, it's getting outputted. As you can see, these are the list of messages that are getting outputted. Our particular custom message that we just defined in our source code, which is FF6C, is a PGN, and 80 is the source address that it gets assigned dynamically based on your sensors that are connected on the CAN bus. So which is the 8-byte information, 64-bit, and it's coming at 100 Hertz, 10 milliseconds. As you can see, all the data is in the hex format. But if you want to get this value in a much in a decimal format so that it's readable, then you can use a DBC file that we provide as well, which I will talk in my later slide. So this is how you can confirm that you've successfully created a custom CAN message with the data packet rate and all the configuration. So CAN DBC file, what is CAN DBC file? This is simply a database format structure around standard CAN messages and signals. So it converts the raw CAN packets, which are in the hexadecimal format, to a physical and the readable format, which is the decimal format. So Aceinna provides a DBC file for all the CAN messages that we're supporting by our products. So as you can see, this DBC file can be opened in any tool. So we can use a vector CAN DBC editor, and you can look at the structure of this message, and you can use it as well for your CAN tool. So the link to the DBC file is as well provided, and it's provided online. And all the documentation for this OpenIMU300RI manual and all the CAN supported messages by this product is all explained in detail in the online documentation. So summary. So Aceina's aim is to enable the quick software development in a short time to market to our customers. So we do that by providing the fully featured software development environment for user application development. So the Visual Studio Code along with the Aceinna Extension, you can get the latest updates to your platform and the source code, and you can change it based on your application needs. We have the code development with the support for different interfaces like CAN, UART, and SPI based on your application needs. We have all the free source code that are available on the GitHub Aceinna, as well as the sample projects as well to get you started. So we have the robust hardware evaluation platform, as you can see on the picture on the right side. So this eval kits that are available for our different products will greatly help you to get you started and customize based on your application needs and be successful. And we have a complete comprehensive documentation for all our products, our tools. Everything is available online, and we have a great support forum with a great technical support team, which are available to answer any of your questions and resolve any of your issues that you have and you to be successful. So thank you. Any questions, we will take it now.
If you have questions, feel free to type them into the chat forum, and we'll try to address them as best as we can. Just in terms of use cases here, we prefer to have questions typed into chat. That way we don't have a whole lot of background interference and noise. So we'll wait for a couple of questions, but great job, Ravi and the team. I wanted to say thank you for that. Also, please feel free to visit our partners' website, which is WPG Americas. They also have inventory of a number of our EVKs, and if you check online on our website, you can actually see their inventory levels and check to see what EVKs and parts they have available to sample as well. So let me check and see if there's any questions in the chat. Don't see any questions as yet, but we will be having a third webinar next month, so stay tuned for that. We'll send out the agenda and topic in the next week or so, and it'll follow very much the same format. That'll be a technical webinar that we'll be hosting as well. And if you have any questions or comments that you would like to follow up with, at the end, we'll send out a thank you email along with Ravi's contact information and James Fenley, who's our product manager, who's also online, his contact information, and of course mine as well. I don't see any questions on the chat as yet, so we'll give it one more minute. If anyone has any questions, feel free to type it into the webinar chat, and we'll try to address them as best we can. All right, doesn't look like there's any questions at this point. So again, we'll be sending out a thank you email to the folks that joined us today. Feel free to follow up with any questions, comments, or concerns that you may have. And we're here to help you get to your end product as quickly as possible, along with our partners, WPG. So thanks very much for joining today. Everyone stay safe, and we look forward to meeting you face-to-face when the situation resolves itself. And thanks very much, Ravi, the team at WPG, and we'll talk soon. Thanks very much.
Thank you, Michael.
Thank you all. Hope you enjoyed it.